Hello students, welcome to MJC Learning. I am Manju Dilip. Today I am going to start with 12th Standard Mathematics Paper 1, first chapter Mathematical Logic Part 9. We already studied the topics circuit, switches, etc. and the input output switching table etc. in the previous video. So today I'll start with the topics constructing switching circuits, interpretation of switching table, an alternate arrangement for the circuit with minimum number of switches, etc. So first we will discuss one question. Construct switching circuits of the following. And the question is here. P and Q and R, or P or Q and negation R. Here three statements are given. So P, Q, R. So for that you have to explain. Let P, the switch S1 is closed, Q, the switch S2 is closed, R, the switch S3 is closed, and here negation R is given. So the switch S3 dash is closed, L, the lamp L glows. Now in the first statement pattern set, there are two statement pattern sets actually. It is connected with the OR symbol. So here P and Q and R, that means S1, S2, S3 are connected in series. So we can draw, you will start from here. So one switch, second switch, third switch, then you have to check what is given after that. There is OR symbol, that means you have to draw or write the next switches parallelly. So here after that, inside that bracket again we can see two sets. So one is single switch and others two switches which are connected in series. So first switch is S1, then you can draw this one S1, and in the third part is here, that is S2 and S3 dash. These two switches are arranged in series. So S2 and S3. Then after completing this part, you will draw this circuit completely by connecting lamp and battery, and arrow marks you have to put and join like this. Then you will finish this part. So start from here, then all switches you will do. So this part you will finish, then connecting all the remaining parts. So the circuit will be over then. Next question is P and R, or negation Q and negation R, and negation P and negation R. Here P, Q, negation Q, negation R, R. This much switches are there, so you have to explain whatever switches are given like that. Then in the here inside the square bracket there are two sets of statement patterns, and one statement pattern is outside, that is AND. So here the first sets you will discuss first, and you will draw that from the beginning. From the left hand side you will start. So this is S1 and S3 are connected in series. So you can start from here like this. So first switch S1, S3 is connected in parallel in series. After that there is OR symbol is given. So that means next sets actually S2 dash and S3 dash are connected in series. So that set is parallel to the first set. So next line you will draw parallelly to the first set like this. Then you will complete that. After that AND symbol is given. That means this much sets of switches are connected to the next set in series. So AND next is inside the bracket again two switches, they are connected in series. So S1 dash, negation P is S1 dash and negation R is S3 dash. This much connection completed. Then you have to complete the circuit with lamp and battery and the arrow marks you have to put. That's it. Again, the next question here, P, Q, R negation, Q negation R is there. So this much you have to write. Lamp L glows. Then here two sets of statements are given actually. So P and negation Q and R, that means three switches S1, S2 dash, S3 are in series. So you will start from this line S1, S2 dash and S3. After that, OR symbol is given. So that means after this, the switches are arranged in parallelly. So next line parallel to the first set, you will start from this line. First is S1. After that, AND is given. That means next set of switches are arranged in series of this. So after that, S2 dash, S3 dash are arranged parallelly. So S2 dash and S3 dash. So you will combine like this and you have to complete this. Then you will connect this with lamp and battery and arrow mark you have to put. Construct the symbolic form of the following switching circuit. Construct its switching table and interpret it. So three parts you have to do in this question. First you have to write the symbolic form of the circuit. Then switching table you have to find. Then interpretation also. The question is here. So here S1, S2, S3, S2 dash, S3 dash. So P, Q, R, negation Q, negation R are given and L you have to describe. So like this you will write first. Then symbolic form of this you have to write. So symbolic form is first is P or negation Q or negation R. All the three switches are connected in parallel way. And this set is connected in series with other set. So and inside the bracket first is P and P is connected parallel to other two switches, that is Q and R. So P or Q and R. Now we have to draw the switching circuit. Switching circuit, you all know now. So three switches are here, P, Q, R. So 2 raised to 3, that is 8 rows you have to make it. Here instead of putting true you will use 1 and instead of putting false F you will put 0. That's it. Remaining all you will complete. And here instead of writing the first, this is statement pattern is A I have given here, and for the second statement pattern set I have given B. So in 10th column you can see A and B. After completing you will get 1 1 1 1 0 0 0 0. So in this circuit you can see if S2 dash S3 dash are not closed and S2 S3 are not closed, but only S1 switch, here it is closed like this and this current will flow like this, then again S1 is closed here again, then definitely the current will flow and the light L glows. So you can write interpretation like this: the lamp will glow if S1 is on and any status of S2, S3. So we don't need to worry about S2, S3, S2 dash, S3 dash in this one. If S1 is only S1 switches are closed, then the current will flow. Next question, give an alternate equivalent simple circuit for the following circuit. So here in this question S1, S2, S3, S2 dash, S3 dash is given. So P, Q, R, negation Q, negation R, L you have to describe like this. Then symbolic form of this is P and inside the bracket you can put Q or R, and these switches are connected parallelly to the other set of switches. So you can close this bracket, or again you have to write all these three switches so that you can put it inside open bracket. Here it is negation R and negation Q and P. Now you have to write the alternate equivalent simple circuit. So you have to simplify this statement pattern into minimum number of switches that we are going to do now. So in the first step, here you can see P and Q or R. So when you're getting a question, you have to check if some switches here or some statement letters are common, or you can make it common, that you have to check it. So here you can, if you are checking it properly, P and, in both of the statement pattern sets you can see P and. The remaining ones you can make it with this one. So negation, if you are taken out in the second statement set, first two symbol you can write like this: negation of R or Q by De Morgan's law. Remaining all we are not doing anything, we are just writing as it is. In the next step you can write P and Q or R, or here you are just changing the order of the statements. So Q or R by commutative law, just changing this order by commutative law. Okay, now in the next step, P and Q or R as it is we are doing, or here you are just changing the position of the this one and this one. So P and this you have written here by commutative law again. Now here P is common in both of the statement pattern set and is common. After that you can see this is Q or R, and here it is negation of Q or R. So in this next step, by distributive law you can take this P outside from both of the statement pattern set, P and you can take it out. Inside the bracket, remaining term in the first statement pattern set is Q or R, or symbol you have to put here. Then the next set, that is negation Q or R. If you are distributing this P to this terms, you must get this one. That way you can check your step also. So in the next step, we'll consider this is P or negation P, like that. So P or negation P is equivalent to T by complement law. So here I am applying complement law for this inside set statement. So P and true. In the next step, P and true is always P by identity law. So now this statement pattern set or symbolic form of this is equivalent to simple circuit, one switch circuit. That is, only P is here, that means S1. Only one switch will be there. So you have to draw that simple circuit for this one. So this is the simple circuit. Next exercise questions. There are two questions given to you. Have to solve it. Thank you.